information security consultant. I earn my wages through stuff like VAPD, Wi-Fi audits, policy-based audits, ISO 27000, yada yada yada. So I won't bore you with other stuff. Electronics enthusiastic, and this year, like we had started learning some new stuff this year. So we were working on some line following robots or autonomous robots and stuff also. So also doing filelcon batch this year. So I'm currently having some R&D into hardware attack vectors also into normal infrastructure. Basically, I have seen, and this is not regarding USB HID vectors as everyone else is expecting, because I have seen multiple people, like in some talks also we have seen that already people have written frameworks also for the USB HID. So this is not a new topic to anybody who is interested into hardware. So basically I am interested into some other R&D into hardwares which might penetrate into from a network layer or similar kind of things. Since it is into very basic structure, I might have some talks later in next year or in other conferences. This is my partner Umesh. We call him like hardware scandal without handle. Basically, since because basically because he doesn't much into online or web technology or like network stuff or any other kind of hacking. Basically, he belongs to the pure electronic and hardware community, and so pure electronic hacker. He doesn't really much involvement into web like other things. For a living, he is into repairing and rebuilding CNC machines as an engineer. And he is the founder of Spartacus Foundation, and through which he does social work in Pune, where he does work for the remand home and street children in Pune. He also does rock climbing and trekking in leisure time, or sometime in full-time business of his. And sometimes he drags innocent people like me to rock climbing, and he will say, oh, this is very simple trekking, we will go for it, and when you go there you will find something like 50 or 100 meters rock like this. We will go up there like this. So sometimes he drags us. So what this talk is not about, we are not going into much details of microcontroller or into deep programming details. We will have just introductory part of this. Programmer, hardware, circuits. In this, we will just have overview of these things, but we will not go into detail. This talk basically we wanted to have regarding, we already have shared information regarding the document basics regarding microcontroller, any other programming hardware which is need, any hardware which can be used to program these chips. In filelcon site also, and I will also post it on my Twitter afterwards. So basically, we are not going in deep regarding these details. We both belong to group Garage for Hackers.
Yes.
Yes. About this group, like as we say, it is you can see we are open security community where we come together very lots of security enthusiasts and gurus, and in multiple topics like from hardware, electronics, and RF and stuff to web technology, reverse engineering, and all the kind of stuff. So if you are interested into any kind of things, you can join us in our domain. Like a little bit about our group, we had last year we had won the bounty here in filelcon for taking down the TravelNet malware. Some of like ASLR bypass you might have seen regarding this presentation. Some of you might have seen in CanSequest. but which was already discussed before that in our forums by our friend Vinu, who is a security researcher. So we have we have multiple people, like we have lots of people from Google, Facebook, Yahoo, Hall of Fame from these countries. We are also regular presenters in chapters in multiple cities such as Bangalore, Pune, and some other cities. Shouts to multiple people, Abhi, Punter, Anil, Chaitanya. All these names are not fitting there, especially Bond for his remote support. So what we would discuss, what is this? So this is a hardware batch. We have made it as a general purpose kit. It contains a Atmega 8 chip. It contains some LED outputs, as you can see, some sound output as buzzers and input switches, and one other gadget. Have anybody of you guessed the circuit? Except you. I know this person has guessed the circuit, and he would be claiming prize. If anybody else has not guessed the circuit, like there were three contests which I will come up to and give the details regarding which. So this is why we have gone for the Atmega 8 chip. Like you can see some of the features of it. It is a small low power chip. It is much cheaper. If you if you are a startup into hardware programming, it is quite a possibility that you might do some wrong settings in the programmer and break your chip. So you should not be stuck with very high end and very high priced chips. So we thought it would be better to start up with a small price chip. It goes for around 80 to 100 rupees depending on which city you are. It has multiple features it has 8 bytes of self-programmable programming memory, 512 EEPROM, 1 KB internal ROM, RISC architecture. It has I have seen a small chip having 23 programs. It is much too less in cost, because I have seen multiple times whenever we are starting something new, like if you are a little bit interested into electronics and if you want to learn regarding some microcontroller and other things, I have seen multiple in market. They are giving some chips which are very high in price. They are giving some circuits which are very costly. So everybody is afraid, like if I do something wrong in that, then I will waste all of the money which I have got into the chip. So basically, its operating voltage is also low. We have used Atmega 8L chip so that we can operate it from a small cell here, 3 volt cell. So its operating voltage is having 2.7 to 5.4. So one important point, that if you use more voltage than 5 volt, then you might burn your chip. So don't use other than 5. Normally if you use just normal USB connector, it would give you 5 volt. And without cell also, if you just connect your programmer here, it would be automatically powered through the programmer and you can use it. So you don't need a different power supply or something. And regarding speed, yeah, please.
Even if you want to use this circuit for higher voltage, you can use regulator IC 7805. It works up to maximum up to 30 volt DC, and it converts that 30 volt to 5 volt. So for protection you have to use it. Or for sale, for 5.5 is worth.
So basically it comes into two grades. One is up to 8 megahertz and one is up to 16 megahertz. Depending on the supply, because Atmega 8 is having low supply, it cannot go up to 16 megahertz. You'd like to add anything on this? Then we come to the competition part. There was one other circuit in the competition. You might have seen in your brochures also this current circuit diagram. So first level of competition for this hardware was to identify this circuit and tell us how it would be working. So basically when we had started, we just had this circuit. Like when we had discussed regarding having a batch for filelcon, we were thinking like having just a small circuit which might be useful to someone in a regular use. So the first thought was to provide only one gadget and this circuit is actually a EMF detector. So it can detect electromagnetic force around it. Basically, it gets activated when you press the last switch. If you switch on and if you press the last switch, then this circuit gets activated, and you can with this circuit you can check out the existence of a like you might say what I might do with the EMF detector. The very simple use of this might be you can detect the AC power supply. We everybody have all of the equipments running on AC. Without just touching to any live wire or anything, you can just keep this circuit near the wire, just half a centimeter or a little bit, some millimeters away. And if the AC current is on, it would this LED would blink. This LED would start. So if this was the first level for the hardware batch, like how this circuit. So I have a LCD 16 by 2 LCD with me, which can be connected here and you can use it. So I have a question for you guys, like if this is the circuit and if you have the same circuit diagram, if you answer this, how right now I have to just keep it 1 or 2 millimeters from the wire to get the EMF detect. Very simple solution can extend the range up to 2-3 centimeters. So if anybody has checked the circuit and he can tell me right now like how this circuit range can be extended, then I will give you a 16 by 2 LCD which can be fitted in and you can use it with the Amey. So I will not hurry it till the tonight end also you can give it. So you don't have to tell right now in the top. I will give you afterwards also. So like here we can see the working of the circuit. When we switch off the power, you can see the LED is glowing. When we switch it off, then it is off. So it is detecting a AC supply, as I said. It can detect other EMF forces also, like if you keep it nearby the microwave, it can detect microwave from that also. It would depend on how much padding the microwave has and depending on the body.
How should I do that? I should go nearby and then press this key, or
yes, that is like a simple power, like a power switch. This key would just simple work as a power switch because it was eating too much power. If we just keep it, if somebody just keep it on this chip and this chip, so it was eating much power. So we just keep it as just power switch. So you just press it there and keep it near.
go near it will.
Yeah. And I think other things when I had made a presentation, I had guessed that more people would have been guessed this particular level. I know you already knew it, so you have not guessed it, Anil. Okay, so
yeah. You also.
you was also there. The second level in the string was hidden in it is a LED persistence of vision. So I had also given a hint that it is related to vision. So basically, what this circuit can do, if you just swing your badge into the air, and it might show you the exact different string. So it might not be visible here, but so I don't know if this. So
How to do that?
you have to press the first key to start it. This, if you just press it for 1 second, it should start. It will start, the LED start blinking. You need to on the switch and to this side. Just press first key and you can do it.
Not working. This one, right?
Yeah, also.
First.
Yeah.
Yeah, now you have to
Now you can just wait.
No.
look at it.
So third level was a string played via the buzzer, which is Morse code. Like if you press this button, second button, you can hear this. So this is actually a Morse code string encoded into Morse code. So I thought many people would be able to solve it, but till now only two people have solved this level. One of them is sitting here right now.
Actually, Morse code is a essential part of last day of Earth ending. So Morse code is a very powerful communication. At any hostile condition, you can communicate with Morse code. So it's a property. No, it's a Morse code is a very
Life survival,
very intelligent tool. Yeah.
And if you are into ham or something interesting, this kind of things, then for a ham exam, it is a compulsory topic. You should be able to recognize Morse code up to 5 WBM.
Oh, five.
So why, like, lots of people might have the question, why are we making this kind of batches? What is the like exact reason behind this? This can be there in market, readily available, some Atmega programmable chip or something like that. But we have seen that comparatively, we have seen in Nalcon also. In like we consider hackers the geeks of the community, overall community. And in the hackers also, we have seen that very less people are involved into hardware stuff. So we thought that like something should be done to get our hacker community motivated, like get them interested into get involved into hardware, microcontrollers or these kind of things. Thank you. We said we can anybody can program this chip by using it. It has a standard USB ASP interface. You have multiple AVR programmers available in the market. Any of those programmers you can connect here and program the chip and control input, outputs and other stuff. You can also connect LCD and LCD can be worked with the same chip also. We have left some pins empty for the LCD connection on this side. And for like normal programming, if you are new to embedded, then basically C language is needed for AVR programming. So embedded, they call it embedded C, but basically it is like 90% or over 90% it is the same. Just some of the libraries are different. So it is nothing there to be getting afraid of. Or if you know C language, you can work on these kind of microcontrollers also. A normal basic simple tool is there, which is called AVR Dude. Normally it is used to transfer the program into the chip. So if anybody is very pretty much new to microcontroller, microcontroller can only run a single program at a time. It doesn't have any OS or something. It has a raw single. You put a compile a program, you transfer it into it, and it would handle the I/O and logic and all other stuff.
What is the span of this particular microcontroller? How many times you can write a program?
This you can write 1 lakh times.
1 lakh times.
Yeah, Atmel in their datasheet says that this can be rewritten 1 lakh times. So that is, I think, more than we can, sir.
Okay, maximum capacity.
Which one?
The microcontroller.
Programmer, it is 512 byte, as I said in previous slides.
Can we connect USB to this?
The programmer would have one connection like this, and one connection would be USB connection. So you can connect it to USB directly, and other side it would be have USB ASP. I'll just show the next slide the photo of the programmer. You'll get the idea of it.
Yes.
So this is
the
why. So this is on the right side. This is a USB ASP sample programmer. So here USB cable could be connected, and this side you will see similar pin like this, which can be connected to any of the boards. So here, what I was coming to the point that we have seen such circuits in the market which are available from 1500 to 3000, just giving a USB programmer and this kind of circuit, which has also similar. It doesn't have a switch or something also. It just has 8 LEDs and nothing else. It has just given different port out. So we thought that if we could get something to people readily available without investing any money, then they might be more going into AVR and other embedded things. So that's why we thought like I am actually pretty much jealous of all the people who are working in US or UK who are working on hardware, because I have seen whenever we are coming like getting any circuit or something done, whenever I go and check for any component, I would like say this is the component ID, this is available in US for this you can order it via post. So for the people who are there in outside, the price, online availability, and I have seen like Eagle is a free software for 2 layers which can do PCB as well as circuit design, and you can see like it would be very easy for anybody into UK or US that this kind of software you can just design a circuit, and afterwards it would just generate a bill of materials. It would say how many components are available on their site, and you can select in the multiple versions of the components and just order it there itself from the site. And when we go here in India, we say the name of the component, no, we have not heard of this component. The shopkeeper in the electronics hobbyist shop also would be doing like this. So this was one of the reasons that hardware hacking in our India is a little bit difficult. So there, as I say, it is much more simple, like just 1, 2, 3, make a circuit, check component availability online, order it, and you will get the circuits. In India, if you check before any circuit building, you have to run across all the market, check the availability of electronics component. Component IDs given in any online material would not be there in India. So you would get something manufactured in China which would not have a component ID. So very much problem. We have seen students, this is also a very much problem against electronic hobbies, that we have seen students are very much threatened again damage to electronic component, like they would say you will burn a resistor, you will burn this thing. Like this resistor comes for 25 or 30 paise in the market, but if you see in college, the instructor will be saying no, you should be handling it very carefully. Let the kid burn some resistor. What's the problem in that? So we have seen that this kind of scenario is due to this kind of scenario, we are having very less hardware hackers in India. So they are not encouraged to experiment and get and saying that something could be damaged or something.
Let it damage.
Yeah, we will say let it damage. So I have also seen very less use of softwares into electronics. Like these electronic community and our software community is like going just two different ways. They would not see to each other. I was very much surprised when we were working on batches. We came across some multiple good softwares like Protus or Eagle, which can be used to circuit design as well as PCB design. And when I had shown this kind of circuits to Umesh, like he is working into electronic market more than I think 20 years. But he was also surprised, oh, how you can do. When I had done the PCB design of the same batch in one day, he was surprised like this, how have you had done this in so much less time? So there are,
It is already, actually it is a very complicated thing to learn those sort of things with all technical recommendations in one day. He's smart guy.
Okay, I will accept that. I was not a smart guy, but let that point be alone. But it is very good tools are also available. Like if you are going into this kind of hardware or embedded thing, very large number of tools are right now available in the market. Most of them are freewares also. You can use it to not only design circuits, you can use it to simulate the circuits. The softwares are also simulating the microcontroller also. So if you fearing that you might burn this, you can just simulate it on your PC first. Check the simulators will have all the components. You can put all the complete circuit on the simulator. Try what it is doing. It would simulate the same thing which might be happening. So you can simulate it, then try on the physical level also. So that was the point regarding the software. So if you are going into embedded, just check out some of the softwares we have also listed in our null brochure, and we will be giving it online also. So coming to history. So as the slide says, we are not going to talking about the hardware history or the microcontroller history. We are only talking about the badge design history. You might say it is so long, little bit. I will try to compress it. So initial idea, we had an initial idea that why not create a hardware badge instead of some normal paper badges at Nalcon. This idea was produced at one Null and Garage for Hackers combined meeting, and my friend Anil, who was sitting here, he called me, said we are discussing about electronics and hardware badges, and your name first come into my mind. So what can we do? So after that, we talked with Asim, Murtuza and Antariksh, other people, and then we discussed like what kind of ideas we could be doing there for this batch. So then lots of R&D was done. So there were ideas such as TV remote jammer, IR communication in between batches. My friend Umesh would be just eager to tell his ideas about the IR communication. So if you want, IR spying.
That was my fantasy.
He wanted communication between the two batches, and he wanted like sending SMS through broadcasting via the multiple batches, so that everybody in Nalcon, like here, I want to send a message to some person. If I know the ID, batch ID, I would send it through IR. Anybody near me would broadcast it again, and that way, after multiple broadcast, it might reach to the person. So it might reach to a person, not a 100%. So in R&D we were working like we at one time we had full 16 by 2 character LCD display with light sensor, temperature sensor, clock, stopwatch, etc., etc. But some ideas were dropped due to money. Some ideas dropped due to less time. We were not getting much time to do R&Ds on some electronic idea, and some due to again hardware components availability and some components having much cost. So whenever you are producing in much larger amount, then you have to again think of the cost lots of times. So like this was the first basic circuit which we had designed. It had a temperature sensor there, a light sensor as well as a LCD, and it was having a menu to select multiple things, like if you want to read temperature, you want to show what is the light sensor reading or any other thing.
I Nalcon that history. Nalcon.
Well, we had also planned that we will have a Nalcon schedule in it. So since it is had a clock, so you just at the time at particular, so if you say you would get like this clock would be there at this location. So these all ideas were there. It was almost completed, but then again dropped due to reasons. This was the first design we had done. Like we had thought that we will give just small, like we have a small size batch, and we'll give just this circuit which we are using as a competition EMF detector. So it can be just used as a tester or something like AC, detecting AC current or something. So this was the first idea, and this is the picture of our first EMF detector. And this is our first POV. So we had built this. We had also some other sensor in it, mercury switch to sense it like that or like that. So this was the POV tool which we were trying to build as an idea. Some switches and interfaces like in the R&D stages, like how we should doing the switches. So at one stage in my house also, my wife was asking, are you ever going to finalize what exactly you are making? Because every time she would be seeing something different we are putting together, then she would ask, what is this? So we would explain, this is the idea, this is the idea. So again one time she said, are you exactly finalized? So after lots of research, we had done a lot of research before finalizing this design. Also we faced lots of problems such as not getting proper components. The local supplier is we had press, I don't know, one local supplier has given a USB programmer circuit which was having a different connections for the USB ISP. So 2-3 times we created a circuit, we connected his supplier, programmer, and when we tried to program, it would break the chip. And we were just mad what is wrong with our circuit. And actually the problem was in the USB programmer who had made, he had switched the MISO-MOSI connection, if you know about the connections.
He wants to sell his programmer as well as his developing kit.
So in his developing kit also these connections were switched and his programmer also. So if you
They were
connect other
working
circuit. So
Practical problems.
So again, the batch size, how much circuit we are putting, how much area we would be giving for other putting the name and other functionalities, what functionalities should be put. So these all I have done. So, but the credits of the R&D, first and important support for our R&D is my wife, Trupti.
Coffee.
Who encouraged us, provided us unlimited supply of food, tea, coffee at whatever time we were doing our R&D. Sorry. And she also kept my little angel daughter Ishani from taking our soldering gun, because whenever we were having some soldering and programming, my daughter was used to come and she was trying to get the soldering guns, so which we were pretty much afraid of. And so it is a long journey from very first prototype when we had fixed the prototype. It is pretty much long journey from the first prototype towards the. So I think Umesh might like to share some
I
thoughts.
want to share some useful tips while making a number of batches. I will just read. One is that first fix the concept, what you have to do, what you are expecting from your circuit. Then draw the circuit, and at what cost. The cost is in terms of time and money. That's the first thing. Design is not our job. Just search for Google God. So don't put yourself into design. That's a very muddy thing. So third, the actual PCB size has to be more than 200%, approximately 200% more than the actual component size, individual component size, the aggregated area covered by components. Your design should be 200% more. Then you should have mounting provisions, because unless you don't think of that, while fitting in a box, there is no mounting provision and you will be in trouble. Though you get high-tech PCB design software, you have to again check what you had arranged or what you have done is as per your expectation. It doesn't mean that you are using higher quality software is giving you higher quality result. Thumb rule. Yeah. Then one line is that asking question is better than assumption. Please. It's a white error. PCB manufacturer requires positive, negative, masking ident, component ident, track view, normal, and oblique mirror. Understand these code words of PCB manufacturer. Okay.
Like when you are doing on prototype or some your personal basis, you might not come under this category. But
Yeah.
if you are the batch maker of next year, you might be. Then you would be coming across these kind of problems when manufacturing in large scale.
Yes. While doing some circuit, leave test points in your design, because after completion of design, it is if you come across some problems, you have to break that design into that basic big problem into small problems, and you have to provide some facilities for yourself. So problem with power, circuit you have to break with power, then IC power, then output power, and input power. You have to check. You have to put checkpoints for those sort of things. So it will help you to get better result in a small time. track width has to be between distance between two track widths should be more enough. So shorting between two tracks, circuit tracks, it will be avoided. If you have any problem with track width or drill size, you have to discuss with the PCB manufacturer, because some PCB manufacturer don't have facility to produce small number of tracks and even a small number of drills. Though they are manufacturer, they don't have that much capacity. So if you design too much and very well organized PCB, it may not be possible for him to reproduce that in a proper way. And then if you force him or he go under some assumptions, and then will be chaos only. Okay. Put minimum jumpers in circuit. You have to put, sometimes you have to put jumper due to the avoid complexity of tracks, but put minimum jumpers. And if you are going to put jumpers, put priority wise as a for supply. Don't put jumpers at first for signals. Then placement of components should be near to each other. So one part of circuit should not be far away from its other relatives. And then direction of component on PCB like diode, transistor should be maintained as aesthetic, and then also that helps for the analyzing of problem. Then tracks between two leads. That is actually not a good practice to draw tracks between components, between two leads of components. It is like someone walking through between two your legs. It should be avoided. But if it is there, then you have to consider that the track width and then the shorting. And because while manufacturing PCB, etching process is really different, and they spray acids on that copper plate, and that if that is under not it has got lost that control, then there will be bridging gaps between two tracks, and if it is small, then it won't matter for you. But if you damage something like IC, so damage is much more, because costing of PCB say 40 rupees, and the IC it will damage, it may be 400 rupees. So think of that. Then while testing, after completion of PCB, see first make a visual inspection of what you are expecting and what is there on the PCB. Though here again, if you are completing your work through professional people, so there is a person behind that organization, and they are making mistakes. So again, you have to think that you have to visually inspect that PCB, and then
You have to hurry a little bit.
yes.
Yes,
1 minute. Then without putting IC, just give power supply to circuit without putting IC, because if there is problem, the IC will not short. Then component will cost 1 rupees, and IC will not. So without putting IC, just go on that. Then don't afraid of for such a sort of circuit. Don't afraid of if component is getting burnt. The resistor is cost for 30 paisa. The diode is cost for say 50 paisa. Then LED cost for 1 rupees. If see all the component bursts, it may not be more than 30 rupees. So be happy.
So a long journey between getting these prototypes and getting first assembled pieces in hand. So after getting hands on first assembled pieces also, the journey was not over. We were testing some of the few samples and we just heard a sound, but so we were just thinking, what was it? So I don't know if anybody of you seen exploding LED. You might have seen exploding capacitors, the resistor might be getting burned, but actually when we had some of our batches, first batches, Actually, the LED broke and
The
it
half.
broke into half, and we were like, huh? What happened? So actually, while doing the assembly, they had shorted some transistor, but due to which the LED just got exploded like a capacitor, but say, giving a sound, and it got into half. So there was some problem, as I said. So before first getting first assembly piece, sample, we needed a sample. We had a sample on general purpose. We needed a PCB to be designed. So sample PCB had to be made and checked to be shown to the other people. So getting one or two sample PCB from the PCB makers is just like getting milk out of the bowl. So sorry for the language, I didn't remember any other comparison while I was making the slides. So we need to finalize the had to finalize the errors in the PCB. Then again finalize the indent, like which is printed here on the PCB before getting the samples. We had to purchase the materials. So I know we guys, we are being engineers, we don't like to get involved into purchasing and other this kind of stuff. But for this we had to
CST.
yeah, CST, BST. So here, while purchasing materials, we had multiple problems. Since too many people were giving too many rates or something, everybody would say that others are giving duplicate material, we are giving original material. And getting the information about verifying genuine components, you wouldn't get that from any known person. And after all those things, verifying genuine component, getting quotation, and then one fine day we had all of the components in our hand, in my home. So then afterwards the came point towards assembly and PCB. So since we are not a regular customers of these guys, we couldn't solder 400 batches ourselves with two guys. So we had to give it to some assembly people. So since we are not regular customer, they would give to priority their run of the wheel jobs, other jobs. We cannot push there for credit or faster jobs or anything else. So we don't have much choices on lower rates. Also, we had time crunch too because we were already late due to the PCB manufacturer, which I would come to later. And assembly was going on till the day before conference. When we had come here, day before conference, then also we were soldering some of the components there, which were remaining. So lessons learned. Being an engineer doesn't make us good at producing mass number of product. To produce this kind of mass number of product, you have to learn lots of things. Some engineer would in your team will always think that highest price things are very good, and he might be not looking at the budget. He would say like, we will have this component, that component, and you would be saying that, oh, I have to multiply 400
So
by the price.
he must hate you, remember.
So also someone would say that if you just show some jazzy circuit to the sponsor and other, then they would just pour in money. Oh yes, please develop all the things.
Yes,
but this was not the case. We had pretty much high advance batches also, but due to economical reasons, we had to scale down little bit also. So we had, while producing mass, we had to think about the price and availability on mass scale. Like sometimes some components you would get on some 5 to 10 pieces, but when you go and ask for 400 pieces, 3000 pieces, 2000 pieces, their availability is not there, timely availability is not there. And anyway they would say anything, like when we were there, they would say from 15 January there is a Chinese New Year, and 15 days all things would be closed. You would not get any components. I was like, huh? What you guys are telling to me? So again, technical lessons also what we learned. One should also check various limits in local area manufacturers and suppliers before finalizing any kind of things. So these are all PCB manufacturer components. These things should be. You also should be checking about the physical things. Like we were also checking, would this sling fit into the PCB or not? How much bigger hole he has put in the sling or not. So this kind of things also we had to take in care. Then making changes in circuit and changing the whole circuit is better than fighting with the suppliers and the PCB manufacturers. So when we are developing on mass scale, like making changes, where if you find like the PCB manufacturer is not capable of doing some small tracks that you have done, then it is better to have like some jumpers and other stuff than to fight with him to get the small tracks PCB, some high-end PCB or something. And while developing on mass scale, more than 100 pieces, you should always, whatever you think that you would be capable of doing it in 2 months, 3 months, just add 1 more month to whatever timeline you are doing it. So it would be better, and start the development beforehand whenever you want these PCBs.
Actually, you have to write down daily data and daily activities, report-like thing. That helps too much. Be serious in that while making those sort of 100 times, more than 100 times.
So some more lessons. Like we learned a lot of lessons through this. So don't involve all the engineers in other process other than R&D. Like if you involve all the engineers into purchasing and all other things, then you would definitely get into problem. Electronic engineer sometimes thinks he knows it all, but it is not the case most of the times. Even the experienced ones. Like for some examples, the electronic engineer would say that 220 ohm would be okay in a replacement of 47 ohm. Chalta hai. But it is not the case. When we are trying out with the IR circuits, it only worked on the 47 ohm resistor, the IR LED. And when we had put the 220 ohm resistor, it was not working. So chalta hai, nahi chalta hai.
Okay.
So 5 volt buzzer is not correct for a 3 volt supply. So you might have, some of you might have faced some problems in the buzzer, like small sound or something. It is because all of the circuit was designed, but we didn't have space and other economics for giving better supply. So we were running on 3 volt supply, and this kind of buzzer, basically if you connect the USB supply, it would give full sound and something, but on the cell sometimes it gives small sound, or sometimes it stops in between. So it is a problem while we had done. So about PCB manufacturers and lessons learned. Like PCB manufacturer, as he said some good thing. I am saying whatever we have faced. He is the person, he would say anything you would give him, he would say we cannot draw small tracks, we cannot drill this kind of size. He would say suddenly, my PCB designer is not available for next 10 days. So whatever you are designing, we will not be able to give you. So he would even try what type of circuit design files. Like we had tried multiple files, like Eagle files or Protus software we had used. So whatever files international standards I would send to the PCB designer, he would say, no, these files are not opening at our end. So what the hell you are using at your end? Just tell me. Because all of the files, I had to send all the standard international forward files when we are doing a PCB design. But he would just say those files are not working. He would also be the same guy who would say, we cannot create a slot like this. You would ask for a slot like this. You would say, no. We are not capable of doing things like this. And like being hacker, we were trying to also stretch them on a different level, like putting some circuits, like some of you might have seen the circuit below at the bottom.
Yeah.
This is actually a complete Atmega programmer, USB ASP programmer. It just doesn't have components connected. So anybody interested, he can get the circuit diagrams we have already shared.
Link is shared there.
Anybody who is interested, who can connect the components here. The components are also not that much costly. You can connect the components and you can have your USB ASP programmer in home also, if you are able to assemble this. And directly you can connect a FRC cable here and program your
10-pin FRC cable with a square head.
So regarding the component supplies, I would just go in faster because we have less time. Like prices, availability, yeah.
Can you tell me what all uses I can have and what all I can try out with this? That would be more interesting.
Okay, like basically it is a programmer, microcontroller chip. So it is capable of interfacing multiple things, like what we had shown, like a temperature sensor, a light sensor, You can connect a magnetic type of sensor. Any sensor which might be possible working on TTL, you can connect these sensors to here. You can got your own program. You can also connect LCD to show your output to these kind of things. And like you can be doing, like we had connected RF chips also, like the chips which are used in car remotes also. These are also capable to connect to this. You can program, like if you want to brute force the RF codes of some car, you can program the brute forcing program here, connect the RF chips at the TTL pins here, and you can try out that also. Though brute forcing is not possible because it is having different circuit to generate a random number, so too much statistics is pretty much high. But you would be able to do lots of things, like any components available, sensor, multiple sensors which are available in the market could be possibly connected to this, and the programming language is also pretty simple. So you could be doing any of this with the same circuit.
You want to add one point? Like
Yeah.
One of the best usage, people are tend to use, tend to design these circuits for POV. You know, we can design or we can use this device to send a gift to our friend and get with the hidden message inside this POV. We can use that. This is
That's
the
a good
best
idea.
use.
Yeah, the smaller
Happy birthday.
the POV persistence of vision, which we saw the nullcon thing is
Instead
that
of
is called as
that
POV,
boy or
persistence
girl's
of vision.
name there.
So
Time between one frame and next frame.
yeah.
Yeah.
So we had designed this one small one which we show earlier, small one. I had designed the small for that same purpose. So I first design in my mind was giving a keychain to the nullcon people, which would only have this kind of 8 LED small one, have one POV, and just if you circle it round and round, it would show some name. So you can change the programmatically, you can change the name. Like we will also share the program. You just change the string in it, and you can have your friend's number, name, and that, and you can gift it to them. It would be a different kind of gift, and it would only cost you some 250, 300 something. Just like that.
Even you can use that for door security. So for instead of button, you use that any input circuitry, sensing circuitry, and for output LEDs, you have to connect 5-volt relay. Then from 5-volt we can change any damn thing. That's
So any electronic cut-off circuits, like you have some IR sensor, you can connect a IR sensor here, and you can connect a relays. So on remote, you can control your electronic circuitries also. So home automation system could be possible on the same
if you connect IR over here, you can operate it from on your normal remote control.
TV remote.
And it won't require any programming for that. I mean IR programming. IR code programming is not needed for that.
We even can have a circuit in this to switch on and off.
No, that is not the
That is not a-
that is the धिक्कार है.
So we hope you like the hardware batch and you do get involved into AVR microcontrollers. So next time I hope to see more people involved into hardware or embedded electronics. So have a nice time hardware hacking. So take care. Thank you. And one more announcement to be done. Like this, we had this competition here of 3 levels. So basically, sadly, no one was able to complete all the three levels. But Mr. Harshavardhan Sharma, who is here, who was able to complete the 2 levels for the first circuit and the Morse code. So we have discussed with the null guys, and since he had
Yesterday itself I said you this nullcon and the Goa, you said nullcon was wrong.
which one? Yeah, you had tell me 2 things. One was wrong. You had come up with one correct circuit here.
No, I said nullcon, you said it was wrong.
Yes.
Yeah, you said it's wrong.
Which this one?
Second, yeah, nullcon.
Yes. It is Goa 2004.
That I said. Goa 2014 I said.
Ah.
That I said, and nullcon also I said to you yesterday.
Nullcon, you said this one nullcon. Again said you Goa regarding this.
No, I sent a mail also for that matter.
Yeah, we have. Okay, we can check the mail also because before okay, before you also this guy was first who had reached to us regarding the answer.
Sequence part.
So in the sequentially also he might get the preference because in that case also only two answers would be there. So we had talked that since no one was able to complete, the guy who reached up first with the most answers, Mr. Harshvardhan Sharma would be getting a free pass for Nalcon next year from the Nal people. So